Okay, we're live. Hi, Joe. Welcome to Venture with Grace.
Hey, how you doing?
Good. Trying to survive. I like the
Awesome.
background setup, by the way.
Oh, thanks. Yeah, it's actually a real background, not a virtual one. So yeah.
Okay, so I want to start with maybe we could start with what's your journey into data engineering? And then for the audience who are like coming from like a business background, maybe if you could give us like the TLDR on data engineering, the differences between like data engineering versus like data scientists and
Mm,
all these kind of like other data domain subject expertise.
yeah. So data engineering is an interesting field. I feel like it's one of these fields that's been around forever, just maybe labeled differently. You had maybe big data engineer or software engineers who worked with data, or even business intelligence developers, retail developers. I mean, these titles have been around for uh, since at least the 1800s. I'm kidding, but a long time, right? But uh, I think with the rise of data science, especially which really came into vogue early 20 what tens, uh, I think saw the rise of data as a first class citizen. I think data was it's always been around. I mean, I've been working in data for late 90s, early 2000s, and um, it's kind of all I've really worked in. Uh, but it it really wasn't like the cool job back when I got into it. I think it was the job you went into because you're very uncool or like,
Mhm.
but we fast forward to 2010s and even to today, and data is very popular. But data engineering, I think, arose in part because of the popularity of data science, and so you had a lot of data scientists who were uh, getting into the field. But and back then, I think the job was very heterogeneous in the sense we're supposed to be, I think one was Drew Conway's diagram of so the intersection of like hacking skills, stats, and domain expertise, and so forth. And so you had to be good at kind of a lot of things, and but that also meant setting up infrastructure and pipelines and all this other stuff that eventually, I think gave rise to modern data engineering in that sense, where data engineering is really responsible for taking data from source systems, um, probably sit more upstream from data use cases, doing something with it, transforming it to make it useful for then downstream use cases. Maybe that's machine learning, maybe that's analytics, maybe that's something else. And so that's really where data engineering sits. So again, it's always been there, but it feels like it was finally given a name, I think in maybe the mid 2010s. And so, yeah, but
Mhm.
it's more of a job that I think arose out of necessity versus being something where people are like, let's make that a career. So
I feel you. Okay, so I think like in the data engineering life cycle, there's like data generation and collection, data ingestion and storage, data processing and transformation, data serving, analytics, and data governance and security. I wonder when you are thinking about these different concepts, like first of all, how do people like let's say if someone work in data engineering at either like a big tech like Google or something versus like OpenAI, what's the core differences in data engineering in the AI age? And then in these like different subsector, I guess since you're the expert here, like can you maybe give us like the quick TLDR on I guess like how does each part work?
yeah, I think it's interesting. So there's definitely classically there's been big tech data engineering, which is where I think a lot of the stuff originated, right? So that was let me just turn off my camera. Following me one second here. But I mean that really was a result of the sort of the age of um, uh, big data systems and so forth, right? And Hadoop and whatnot. But that was solving problems that are very particular to big tech. If you kind of zoom out and understand the landscape from non-big tech, I suppose it wasn't. Uh, I suppose there wasn't really as much need, right? I mean, you're talking about smaller data sets. Let me just fix my camera here real quick. Yeah, smaller data sets and just typically more pedestrian type problems. Whereas the big tech companies are inventing systems that are very um, acute to those types of problems. But then you run into situations nowadays with AI, quote unquote. Hey, Mary, how you doing?
Mhm. I'm
Um,
very-
she's the goat too. But
yeah.
you run into situations, these days, and what's I don't think the problems have really gone away per se. Let me just turn off my AI tracking on my camera here. But the what's happening is you're more starting to see an intersection of a variety of different use cases and types of data traditionally that weren't top of mind for data engineers or ML engineers, for example, right? And so data engineering now is moving more towards dealing with multimodal types data use cases, whereas in the past it was typically structured or semi-structured data. Now you could be dealing with text, you could be dealing with all kinds of stuff. And so, but and I can't speak for big companies like that are doing this stuff because I don't work there, and a lot of these systems are proprietary and whatnot. But I know that a lot of my friends that work at these big companies, they do say the tooling is amazing. But the job of a data engineer, typically, it's you might be building these systems, but more, I think you're just using the systems that other people have built for you and using that to just deal with just unfathomably large data sets. But yeah, AI has changed the game where, again, like my background's in machine learning and probably more like classical type machine learning. But back then it was, you might be using GPUs, but tabular data sets are pretty easy to work with. Actually, I say tabular data is actually really hard to work with. But you have well-established techniques, whereas now you're having to think about how do you combine all the different types of data together. And it's just opened up a whole new world of possibilities. On the flip side, too, you're also using AI to, as an engineer. So it's copilots. It's asking questions about system design and so forth. And so it's a pretty cool time. Yeah. I think I answered your question, but
Yeah,
anyway.
I feel like my question is very open-ended too, just because
Okay.
I'm not sure what I know or not know. So like, okay, so um every day I feel like living in the startup land, like a lot of people are um training AI models or AI agents. Like from a data engineering perspective, like what are things that are interesting you feel like startup could solve these days?
I mean, it is interesting. I think the kinds of problems I think would not be interesting or would be really difficult for startups to solve is um, like coming up with a new foundation model, for example. It's just, unless DeepSeek's math is correct and they trained it for, a substantially lower price. But that aside, I do see this. There's a lot of interesting opportunities right now where you could take things from an AI first perspective. And I think internally using things like agents and um, AI to streamline up just internal operations. I mean, I started a new company and I'm fully all in on that type of a use case where let's see how far I can use AI and also just or use AI to help me create automated workflows and stuff within my company, right? So that's a lot of stuff I've been thinking about. Agents is an interesting one. Enterprise agents, I feel like that's going to be more discussed and worked on more. I think there's a lot of agent frameworks out there right now, and I think companies are starting to unveil things that, Operator was just announced, released not that long ago, and but it also feels like the security protections aren't there yet for, I would say, widespread adoption in enterprise. And I think the other part of it is, even with people like myself, like how willing am I to let an agent roam on my computer and do things or on my production servers? Because you're dealing with probabilistic use cases, right? And I think with sort of fuzzy boundaries. And so I think that's, where I've been sort of personally trying to figure out, like, where is this stuff going to be useful for what I'm doing, and what could be useful potentially for customers and so forth. But yeah, I don't know. It's sort of the Wild West at this point. I don't think there is a rubric, kind of a go-to-market play for like using AI agents for your company, either to help your customers or internally. I think people are literally trying to figure it out as we go, which is exciting for sure in a lot of ways. So
Mm.
potentially scary if these things sort of get out of control. But I mean, just don't give it too much access to your production databases just yet.
I wonder what's your thought on like OpenAI Deep Research that was launched yesterday?
I think it's interesting. So I've been using Gemini's version of Deep Research actually for
Mhm.
a bit since it's been announced. I've been actually using it to help me write a book.
Mhm,
It's been amazing. Not like write the book, but for book
mhm,
research, and it's been amazing actually. I've yet to try out OpenAI's version of this, but I have the paid version of Gemini, and I was pretty shocked at how thorough it was. It would, you give it a something you want it to go research, and it'll come back with several dozen links that it can go look at. I'm like, that's pretty cool.
mhm.
Have at it, come back with stuff, and I think the depth of the research was very impressive. Again, I think OpenAI, are they charging like $200 a month for it though? So yeah, so I'm like, maybe I'll sign up for it if I can get every kind of the kitchen sink included. But yeah, have you tried it out?
I haven't yet, but, like, I'm planning on trying because I don't think yeah, like, I feel like it's too early and have not do anything yet, but from my understanding, it's just, like, giving you a bunch of links, right?
Yeah, but then yeah, exactly. They'll go through and sort of summarize or research a topic on it. Yeah, that's pretty much, at least that's what the Gemini version does.
Yeah,
Um,
so what's your, like, I guess, like, for DeepSeek, like, I guess, like, from a coding perspective, I mean, because I feel like as a regular consumer, like, my topics are generally very basic, so, like, whatever I search on, like, OpenAI or Anthropic or, like,
yeah,
Perplexity is kind of the same thing, but, from, like, a coding perspective, have you tried DeepSeek? And then, like, what's the major differences between DeepSeek versus the existing models?
I haven't tried the open source version of DeepSeek just yet. I did install the iOS version
Mhm.
um, to check it out, but then I started probing around in it, and I promptly deleted it from my phone. So it's just one of those things where I looked at the terms and conditions and the types of responses I was getting back, and I was like, yeah, probably not today. So I haven't tried the open source one. I'm actually really interested, and I have the a DeepSeek paper queued up on my iPad. So in the afternoon, I ride my spin bike for about 30, 40 minutes and just read research papers. So, and this is the one I'll probably be reading today. But I think it sounds like they have some good advancements, but I have not tried the open source one yet. So, um,
I wonder, so, like, I mean, since, like, I wanna go back to some of the basic questions, again, like, I feel like our audience have, like, different range of, like, technical knowledge. So like I would say like so some of them are like genre startup founders maybe in the customer space or like in consumer tech space or like just like business founders that are like coming from a business background. For those who may not be like super familiar with like the data language, if you could like give us some background on like the data models and architectures, what's actually involved in like let's say building a foundational model versus like building like an AI agent, and what's the difference between like a like AI agent versus like GPT wrapper, because people always say it's like a GPT wrapper, like you just like pack ChatGPT with something else. I guess like since you're the expert here, like I want to hear your thoughts on like
well,
what's
for
the
full
difference.
disclosure, I've never built a a foundation model from scratch, and so I can only give you what I've know third hand and stuff.
Mhm.
Um, but in a lot of cases, to the best of my knowledge, again, I haven't built this. I have friends who have. I mean, you're going to start with, so from a data perspective, right? Um, this is incredibly important to know, right? So kind of rewinding a bit, there's a whole approach to machine learning. I guess that's called AI now, but
Mhm.
called deep learning, right? And
Mhm.
so the whole idea is to basically use neural nets and basically through many passes you come up with a better answer to some sort of problem you're doing. And then around 2017, Google figured out a way to utilize deep learning with a tech, to improve translations, right? So they had the transformer paper. This came out, and this started revolutionizing things because what it meant is you can give inputs and get very interesting outputs. Very kind of depending what you train it on, very human-like stuff. And so, from a text perspective, I think this is the one that most people are familiar with. You want to, again, from a data perspective, you want to get data that would be interesting and representative of the type of model that you're trying to build, right? So if you want to have a model that will provide answers, like for GPT, you're going to, that's meant to be a very general model. You want to get basically all the data on the internet and text data, that is. and comb through that, right? So, and then basically you take the data, put it into chunks. These are called tokens, and then then that is trained using a lot of very expensive processing power, and eventually you have a model, right? And then you can further advance this model. But the thing is, from a layman's term, then you can basically interact with this model, and it'll give you answers back. This entirely depends on the data it's been trained on, of course, right? And so this is one of the cruxes of at least in the world I live in, is what's the kind of data that this model should be trained on? Where does this data come from? And I think increasingly what you're going to see is companies using this data, using their data in these models. I think by a lot of accounts, the data that's been used to train things like ChatGPT and Gemini and so forth, that's been basically they use a common crawl data set, I believe it is, which is kind of publicly available data that's been scraped from the internet. But I think the common thing you're hearing is that we've sort of reached the end of that data being available, because we've kind of used all the data. So I think for me, what's interesting is the next frontier of all the data that's in companies, and how that can be leveraged, right? And what kind of data should be used, what kind of data. Again, this goes back to the privacy protections, as enterprise protections, as mentioning earlier about agents, but what should be used, what should be guarded, and so forth, right? And so that I think that's. And then there's some talk that maybe these big models like ChatGPT are great, but maybe they're too general. Maybe you need to have smaller models that are more contextually appropriate for companies. And so that's it's a fascinating space to work in, for sure right now. And I think we're just getting started. But if you figure that it's the interesting thing is there's a lot of data that's in company databases, for example, structured data, but then there's a lot of text data, whether it's emails, chat transcripts, PDFs floating around. So how do you combine all this together? And then I think more importantly, how do you give it domain context? So it just doesn't bring in data, but it also understands your business. At the end of the day, these things don't really understand anything. They're just it's just math. But how does it know the domain of your business? So I think that's a really exciting area, both research and application. You're going to be seeing more of. So, but that's, I think, generally from a data perspective, that's how you got to think about it. Like, what data should you use to train these models? And this is basically, if you take a step back, this is how you would think about machine learning in general. Like, what's the data you're trying to train a model on? What is it? What is the intention of this model that you're building? Is this data, does it accurately represent what we want it to do, or what we're trying to represent? Is it biased, or does it overweight towards things that may train the model to give outputs that may not be desirable? So so there's a lot of considerations you have to have there. So
I wonder, so like since you mentioned like briefly about like there is, I guess, like structured and unstructured data, and like the word data maybe like already about to be finished. So like I want to maybe touch upon like the data pipeline and the ETL processes. So ETL, for the audience who may not know, is extract, transform, and load. Can you give us like maybe like some explanations on like how does that work? So for example, let's say like for a foundational model to work, or for anything to work, what kind of data are we actually collecting, and what is like useful, what is not useful, and then how do you, I mean, I feel like people probably seen the Andrew Parkarthi video of like, let's say there's like, is this a cat or is this a dog? So like, but after
yeah,
that concept, I don't know, like how does it kind of like actually process to actually generate some sort of answer? And I know it's like kind of, I know DeepSeek was turned something from like 32 to 8. Like what does that mean? Like I'm sorry, like I literally have
yeah.
the note somewhere in my notes, but yeah,
So I'm not familiar with the 32 to 8 thing, but what I can say is, like, in general, how you want to think about this is, so if you take a step back, right, there's different types
yeah.
of data.
Mhm.
there's structured data, which is commonly, and all data is somewhat structured, so this gets a bit weird, but
Mhm.
like tabular data, we'll call it, right? So like you have
Mhm.
rows and then you have columns. If you've used Excel, great mental representation of this.
Mhm.
And so that's kind of how that works, where you have the um, you know, rows, columns, all that stuff. One second here. And that's a lot of where classical machine learning, and even deep learning approaches, um, came from. Right? Is how do we
Mhm.
take this square or rectangle of data, which has to be all numerics, by the way, and then how do you take this data and make sense of it, right? So the processing of this data basically comes down to everything is has to be a number at the end of the day. So I'm just giving you kind of the 101
Mhm.
version of the audience 101
Mhm.
version of data it looks like. Um, but the interesting thing is, historically, before deep learning came around,
Mhm.
data, you had to pre-process, say, images, for example,
Mhm.
and all this stuff. But now, with deep learning, it's not as necessary. You basically just need to, and things like unstructured data, which would be things that aren't tabular or semi-structured, right? So semi-structured would be like JSON data or
Mhm.
XML. But when you're talking about data that is unstructured, commonly that's going to be images, text, video, audio, and so forth, right? So as an example, if you take an image, right, that's typically going to be something that has a square shape and a number of pixels and RGB colors and so forth. And so you can basically just take the image and throw it into these models, and it'll just pre-process it for you, which is really,
Um,
really cool.
I'm
So
sorry.
yeah.
How does like the machine process an image and how does that translate into data? So like for example, I
Mhm.
know that you mentioned about like the
Tabular. Yeah,
tabular data. So that's kind of like is that like the 0101 thing or is this like a
could be.
different number?
Yeah, so if we take tabular data, for example, and this is something where I think it's a lot more hands-on, so these examples will hold.
Right.
When you're talking about tabular data, right? So if we had say a spreadsheet of, I don't know, like names, addresses, zip codes, city, state, that kind of stuff. Um, that in itself is text. Those fields are text, right? Somehow those have to be converted into a number, and so you might have different ways of encoding those values, right? So Grace Gong could be a name, but that would have to be a number, perhaps. So
Mhm.
maybe we assign that maybe it's an ID, or maybe it's as you point out, a one, but that or zero, or so I think it depends. Like this is what's called feature engineering, and it's very. I think
Mhm.
it, especially when you're talking about tabular data, this is a very it's part art and science, but at the end of the day, you want to basically convert all those values into something that's a number, right? So that what you mentioned as ones and zeros, that's commonly called one-hot encoding. So
Mhm.
if you had, say, and it works really well if you have a limited number of attributes. If you have a bunch like names, you could imagine that like you would have basically ones very sporadically
Mhm.
sparsely populating a data set, but then you would have zeros everywhere else, which is not
Mhm.
terrific. It's hard to get signal out of it. So there's different ways of encoding, but at the end of the day, what you want to do is you want to take that data set and convert it into everything has to be a number, and then you throw it into um, an algorithm to train the model, right? So, but what normally happens before that is you want to have some sort of objective, right? Like, say that the spreadsheet that you have, I'm using as a very tiny, tiny example spreadsheet, but you could say it's a database and basically the same thing. But say we want to figure out like, uh, I don't know, uh, is this person well, maybe we'll actually call it pet names, right? So is this a cat or a dog? Based upon the name or something like that. I don't know. So if you had a name called Fluffy, I don't know, maybe it's a really long-haired cat or it could be a dog. But ultimately you would take all these attributes and the label at the end would be the thing that you're trying to identify, and hopefully the uh, algorithm will be able to identify. Once you give it new inputs, it would say, okay, that based on everything I know, that seems like that would be a dog, right? But that's for text. That's for tabular data. What you mentioned with Andrew Karpathy is that you could do this with images, and basically it's sort of the same thing where you'd have images of cats and dogs, for example. They would have labels, and then cat, dog. none of the above, maybe, or ostrich,
Mhm.
and then you'd be able to train a model off that too. But it's all kind of the same thing. Basically, you have an input, an expectation of what it should be, and
Mhm.
train a model, and then with new data that comes in, um, you're trying to predict what that thing is, and so that's how that type of machine learning works. So that's called supervised machine learning, which is not really the same thing as what we're trying to do when we're talking about like building a text, like an LLM or something like that. That's mostly unsupervised learning, where you're letting the machine actually figure out what the answer is, without human intervention. And a lot of that's just because there's so much data. If you would imagine training something like a ChatGPT, I can't imagine trying to label these things. Maybe a machine could do it, but it would just be a lot of work. So
Mm.
hopefully it
Uh,
answers the questions. I know got
for
up
sure.
into the
So, like,
weeds a bit.
is there like a graduation journey from like a supervised training to unsupervised training?
I don't know. I think that it's more just what are you trying to do. I don't know that it would be like a graduation where like one's uh well, it brings up an interesting point though, right? Where um it does depend what your use case is and how much time, compute, resources, and so forth you have. So I think that that's part of it. Like if there's, I think right now that all the attention is on like large language models and AI. And so I think that this is sort of how everyone thinks that we should be solving problems these days. But there's a lot of utility in using really simple models, things that you can just run on your laptop, basically, if you needed to. So I guess the question is, if you needed to calculate like 1 plus 1, I mean, are you going to
Mhm.
pull out like Excel or your, a huge calculator or ChatGPT, or you could probably just use pad and paper for it. So I think it's more of like what kind of problem are you solving, and what's the so there's a really good paper that came out last year that talked about um, sort of the scaling laws of you know current AI, and whether it's actually better to use more old school techniques. Uh, Old school meaning things that have just been around forever and are a lot simpler. And so one example they gave, I think it was a research in epilepsy patients, where they actually found like using sophisticated AI models didn't really use much more. It didn't produce better results, but it's obviously way more expensive and used a lot more resources. Whereas something like they called it, it's a technique called logistic regression. And so what you're doing in that case is you're just trying to figure out, what's the probability boundary of something happening. But you could do this in Excel. Is the whole point. Like
Mm.
you literally code this in Excel, and it would work really well. And so the question is, and the thing is, logistic regression performed just as well as these very expensive approaches. And so I think the question of graduation is interesting, where a lot of the attention is on using very sophisticated AI and so forth to solve problems. But I guess the question is, if you were to do this in production, uh, is it worth it, or are you better off trying to do something simpler, right? And so,
Mm.
but then there's this whole notion though, and this is coming from my friend Chip Wynn. She has written a book on AI engineering, where she did a very good job delineating between classical ML, machine learning engineering, and AI engineering. And I think her thesis is nowadays with AI, being widely available, whether you're talking Claude, Gemini, OpenAI, whatever, all these APIs, and Lord knows how many AI companies out there. Like a lot of these problems you'd be solving with traditional machine learning approaches, and all the knowledge you have to do that. And it's like, well, do you move faster just by doing quote AI engineering and just using these ready built models instead of rolling your own, I suppose. So because one requires not as much machine learning expertise, the other one requires machine learning engineering requires obviously a lot of expertise. And so it's an interesting time because you can get a lot of leverage off these widely available AI models. Like I used I was doing using Claude this weekend actually to build um, like a massive Docker container, like something that I don't really do that often. So Docker's way of containerizing an application. It was very complicated, but I think within 3 hours I had something that worked really well, and that would have taken me probably a few weekends to get done. Right, and so I think that was super cool to do.
Mm.
So yeah.
Before we get into the Docker container, I want to maybe start with I feel like we uh briefly talk about ETL. So it's extract, transform, and load.
Mhm.
So basically, how is like my data being pulled? So for example, let's say I'm doing like a finance chat GPT or some sort of like, or like legal chat GPT. I like lately, like I feel like a lot of Silicon Valley companies started like focusing on legal or like these traditional industries, like leveraging AI to like improve the efficiency. Um, how does it work in the back end? So for example, the data pulling from where? So like for example, let's say I'm working with like a legal firm. So what data do I have to like upload? And then I know there's like the rational databases, and then there's like the IoT sensors, and then there's like flat file, and then um other stuff. So I guess like first of all, like where does the data being extract? And then how does it transform? So for example, standardization, cleaning, mapping, augmentation. I guess like how does like for example, let's say we're building like legal ChatGPT, like uh how do we standardize this thing? Is that just like the notes that have a title, have like a case study, have like the result, or like I guess like how would you process these like data?
That's a good question, and I've never had to build a legal chat GPT, so I would be it would probably be a bit of a project for me to figure out the data. But I can walk you through the mental process actually of how I would think
Okay.
about this, right?
Yeah.
How I think about this is, what if we were to build a legal chat GPT, and I suppose what would it do? Like, what's the purpose of it? And then who would be using it, right? So I always start backwards from the user and the consumer, and then try and figure out okay, so how are we going to do this? So let's take a hypothetical example. So say that let me see. So my sister's a lawyer. I'll take what she does. So she
Mhm.
is a contract lawyer in the oil and gas industry, right? So her job consists of reading a lot of, so she has to do a lot of research in terms of, in this case, maybe who owns what land, and more importantly, the mineral rights for this land,
Mhm.
right? So you can imagine that if you're in oil and gas, you want to make sure that you're clear to go ahead and uh, drill on these parcels of land, and not owe anybody a bunch of money. So I would, in this use case here, probably a new startup idea for somebody, in the oil and gas field. So the way I would approach this problem is I would say, okay, so like the documents you're currently using, what do they look like? How many of them are there? Right? Are you using the same ones over and over, or is it new every time? And then what kind of questions are you asking? When you look at these documents, like what are you trying to do exactly? In this case, it's to evaluate whether or not you have the rights to these particular maybe lat long coordinates, or this land it's identified legally, right? And so land is you have to do surveys and all this fun stuff. But I try and figure out like, okay, so like what are the docs, what are the types of questions we're asking, and what's the goal that you're trying to accomplish here, and how does AI actually speed up you achieving this goal? Am I actually, or the question I also need to ask is like, if I do this, am I creating actually more work for you at the end of the day? Because the whole point of this is to streamline your work, not make your life more hectic and whatnot. And so that's how I would start. And then I would just collect the documents, um, that people would be using, try and get as many of those as possible. And so in this case, I think it's interesting. So the approach would be: do you want to train a new model out of this or not? I would um, probably just do something like RAG, which would just be supplementing an existing model with the data that I have, and build something off of that. Um, but otherwise, if you're starting from scratch, you would just take those docs and just train it according to however people are training the you know latest generation of models these days. So if you had a huge corpus of this data, for example, then you know you might be worth your while to try and train it. But generically, that's how you do it. So the extract part would be extracting the data from whatever sources it is. Um, Transformations is an interesting one. So full disclosure, text isn't really my forte, but I would definitely look at it from like what data would be necessary to train this in. In a text document, what's all the extraneous stuff that you don't need? right?
Mhm.
So, and there's the thing is in text, there's probably there's the information you want, but there's a lot of garbage information that you probably don't need. Um,
What are the stuff that you want, and what are the stuff that, like, doesn't matter?
that's where you got to talk to the domain experts, and I would say understand like what it is that they're looking for, right?
Mhm,
Um, and so if you were to take a document and draw a circle, like, or have
mhm,
people use GraphRag, yeah, you could do that. Um, yeah, exactly. That's what Crispin said.
mhm,
Um, but the way I would do it is just a lot of it comes down to just understanding like what information is valuable to the person. Like my sister, for example, when she's looking at a doc and she has to read like probably hundreds, maybe thousands of pages of this stuff, like what are you
mhm,
looking for? And I would zoom in on that, right? So,
mhm,
but again, I don't know the types of docs she looks at. I think my eyes would bleed if I had to read the stuff that
mhm,
she has to do. But that's essentially how I would approach the problem. Again, not having built this model and not having you know, uh, again, disclaimer: text isn't my forte, but that's how I would think about solving the problem. And so, but this is how you would solve basically any type of data problem in general, right? If you take a step back to data engineering, it's like asking what is the type of problem we're trying to solve. What's the data you're using? What's the data that's available? How are you currently solving the problem? That's a big one that you need to understand. Like, what is it we're trying to automate? Because if you take a step back, right, machine learning is one of these things where you're trying to scale what humans are probably doing, but because of bandwidth are having trouble doing. So an example I always like to give is if we had to, you brought up the cat and dog classification thing, right? So if I had to go in class, if my job was to go classify 1 million images by myself, I would probably be really old by the time, and I probably wouldn't get that done, right? That's where you'd want to use machine learning, right? So it will scale what people have been trying to do on mass, and so that's how you got to think about this problem too. Like generically, like if we were to come up ChatGPT did this really well. People want to ask questions of data, right? Um, and as far as I know, it's an interesting side note. The whole transformer model, was created, but when the people started interacting with it, it was almost freaky because people didn't understand. Like, I think it caught people off guard. Like, you can ask it questions, and they'll give you these really good-looking answers back. Like, I don't think that was the expectation of it. So, so sometimes I guess I guess to counter what I just said, things sort of happen out of the blue, and you need to understand that too. Where you know,
mm.
but generically, like ETL, if you think about that, and you asked about ETL, so I'll talk about that. But that's just, you got to understand what data you're extracting. If there's any transformation involved, what does that look like? And
What is
then bring it in.
transformation involved, or what does
So
that mean?
it's interesting because when you're talking, it depends on your use case, right? So ETL was an acronym that really came about to address analytical data needs, not necessarily machine learning, right? But it also came out in an age where machine learning wasn't really a thing because ETL
Mhm,
as a practice came out in the late 80s, and became popularized in the 1990s. But it was really a way to give it take a step back. The motivation behind ETL was you had these production source systems, and you got to remember back in the 1980s, especially in 90s, the source systems were production databases that if you so much as breathe on these things, because of resource constraints at the time, storage, memory, and CPU, they were just very frail, and they were meant to handle the transactions, the operations of a business. Doing analytics on these things was typically not a good idea because the analytical queries are just fundamentally different
mhm,
than transactional queries. They tend to scan a lot more data and put a lot more pressure on the database. And so this is when the data warehouse came about, if you've heard of that. So the data warehouse was
mhm,
really an attempt to give analytics a dedicated place off of or away from the operational systems. And so the data warehouse was available to basically do analytics. And then from there, it was interesting because then you started seeing like ETL becoming the way that you would load data into the data warehouse. And so that's so the ETL, extract, transform, load, was a way to extract data from production systems, transform it, the data in flight, into something that would be more amenable to analytics downstream. And the transformation step is really the result of or one of the reasons was it was too computationally intensive to do the transformations in the place where you're loading it, or in the place where you're extracting it from. And so there's sort of this middle layer where you'd be doing the data transformations and loading it in to your destination, which is where the analytics would happen. But since then, and this is a paradigm I think that would start having parallels to machine learning workloads, is in the last 15, 20 years, storage and compute got really cheap. So now there's this whole notion of ELT, which is extract and load and transform. So you just extract data, load it into somewhere, probably in the cloud, and then you can transform it to your heart's content, right? And so this is, I think, important to note, is what you've been seeing is because when you extract data and load it into maybe say object storage, which like Amazon S3 is a good example of that. You can do a lot of things to it. You can run analytics on it, right? But you can also create machine learning models off that same data. And that was a luxury that you didn't have back in the ETL proper days. And so what you've seen since then is just being able to load data in, and this is sort of the heart of data engineering and where it starts intersecting with machine learning nowadays, is traditionally the data that data engineers were loading was used for analytics for the longest time. But now what you're starting to see is the ability to use the same data and supplement it with other data to do things beyond analytics, right? So this is training machine learning models. It's using it in AI and so forth. So what you're seeing is sort of this melding of different data, which is pretty cool. But anyway, hopefully that answers your question on ETL and ELT. I can go on if you'd like, but
Yeah, totally. I wonder, since like we also talk about um like the technology. So for example, you mentioned like Hadoop, and then I know there's like another one, Spark. So basically I'm aware of like Hadoop does like data storage, data processing, and resource management, but how does it work? I mean, I feel like I hear about this a lot, and then I know it's like open source framework, and I wonder I how does it work? People always like very highlight on the open source stuff. Like obviously that was like there's two school of thoughts, like open source is better, like closed source is better, yada yada yada. But like for like a regular person, like what does this mean? Like what does Hadoop work? And then what is Spark? And like how does this like kind of help people, you know, from data storage, processing, and like
yeah.
resource
And so
management?
Hadoop is really so if we kind of zoom back to, or rewind back to
Mhm,
the early days of the web, especially around the early 2000s. A lot of these companies, Google, Amazon, definitely these are the scales, and Yahoo, right? At that time, they're trying to scale as the web grew, and they were using traditional relational database technologies to store and process data. What would happen though is these systems where, they weren't designed for the scale of data, either ingestion, storage, or processing needs that these companies required. And so they started thinking about, okay, so how do we think about this from first principles? If we have data that's growing a ton and we're trying to process a bunch of it, these relational databases aren't cutting it. What else can we do? And so this is where you started looking around. You're like, okay, so there's commodity hardware, there's servers we can
mhm,
use. If we were to have just commodity hardware and distribute computation, or distribute our data across these and distribute our computation, what would this look like, right? So instead of doing things on one box, if we were just to leverage cheap compute and do it this way, this is where things like MapReduce and Hadoop came about, right? And so actually a friend of mine, Amr Abdullah, so he was working at Yahoo at the time, and he told me about when Hadoop actually came about at Yahoo. They were trying to solve this really complicated problem where they're trying to correlate a bunch of data together, and it just would never finish on these old relational databases. And so they started using this. There's a paper called MapReduce that came out of Google where they talked about solving this exact problem. Basically, taking data, mapping the computation or algorithm to the data, and then running it and then reducing it back. I know it's complicated. I'll get to the punchline in a second. But what this opened up was, stuff like Hadoop, which became this ecosystem of storing, processing, to some extent orchestrating data as well. In in a way that you weren't tied to a specific vendor or a database technology. And so that was really the first manifestation of what became the big data era. There's a lot more to it, but you can kind of think of that. And so that deals with like data that moves at high velocity and high volume and has a lot of variety to it. But the problem with things like Hadoop was it was slow, and the MapReduce paradigm was a bit complicated. Slow because you ran a lot of the computation on disk, which is just like horribly slow and inefficient. And so along comes Spark, right? I think research started this at the Berkeley Labs, as Reis or whatever, back in 2009, I believe, even earlier. And that was an attempt to basically make this whole MapReduce paradigm work in memory. There's a lot more to it than that, but but that really opened up people's eyes to the fact that you can start using open source, right? So these are all open source projects, and what this meant was, if you had large processing needs, you wouldn't have to go to a vendor. You could just run the stuff on your own. So one of my friends, John King, I think he was the fourth installation of Hadoop in the world, the first production or fourth production user in the world on that, and he used, I think, processing a lot of image data or something at the time, and Hadoop fit his needs. This back mid 2000s. And so you start seeing an explosion of interest in these open source technologies and these paradigms. And, you fast forward to today, and this is sort of what underpins a lot of technologies in the cloud even, right? If you look at sort of the consequence of things like Hadoop, there's the Hadoop file system, and later Hive and Hive Metastore that's still widely used, underpins a lot of technologies in the world, at a lot of big tech companies. And so what does this mean? Right. It means like people are able to, basically have their choice of software, and how they want to store and process data. And you fast forward to today, and it gets really interesting because you have technologies like Apache Iceberg that I think are sort of the successor to a lot of the older technologies, and that provides a universal way of storing data, and in object storage now. So it's just things have gotten cheaper and better. So I think there's a lot of things I probably missed out on your question, but I think I answered it probably 15% of it. I don't know. There's a lot to unpack in what you asked. So
Maybe like we could talk about like since like we talk about Hadoop, but there's also like data warehouses and data lakes.
yeah,
Um like I feel like there's like so many different concepts. Like what do you think is like the most important to cover? We could also cover like SQL, not SQL databases. I feel like those are like the buzzword or keywords I've heard over and over again that like
yeah.
even watching like the YouTube tutorials on these things, like I feel like it's very abstract to understand for like a
There's
regular, I would say like a normie.
Yeah, I mean, if I try to break it down to first principles, right? The way I kind of view these things is you're going to need a few things. You're going to need a place to store your data, right? And you're going to need
Mhm.
a way to process it and query it. And so, and by
What
processing, I
does
also mean
query it mean? Like I
querying
know
it would mean
yeah.
to ask it. If you were to think of if you were to ask a question of your data, right? And so, um, so say I had a um, just some data. It doesn't matter what shape it's in. We'll call it a table for argument's sake. Say I want to pick, and this table contained customer information,
Mhm.
right? Say I wanted to figure out my top customers. So if I were to break this down to pretty simple terms, it's like I have the data stored somewhere,
Mhm.
right? I'm able to query it using something like SQL. So SQL would be a way I can talk to my data that's
Mhm.
stored in maybe a place like a data warehouse, right? So a data warehouse is simply just a place where you would put your data to ask it analytical type questions. So in this case, an analytical type question would be, who are my top customers for, I don't know, 2024, right? So I would use a SQL, which is structured query language,
Mhm.
to ask questions of the data, right? So this is typically going to be a select something from a table.
Mhm.
And if you look at your SQL tutorials, it'd be where, uh, you know, you have some conditions on what you're asking. Um, Thanks, Mary. She loves my storytelling. And so this, but then you'd be able to just like if if you're to ask a question to me, like like Joe, what are the top customers for 2024? I'd have to think about this. I'd have to think like, okay, um, I had all these customers in this activity in 2024.
Mhm.
Okay, let's start there. So that's the first pool that I'm going for, is like within this year of 2024, I have these customers. And then I'd have to ask the question, okay, so you want the top customers. What do you mean by top customer exactly? Is that by sales? Is that by volume, right? And
Mhm.
you're going to say, well, probably by dollar revenue, right? Okay, great. So now we have a few things, right, that we can make our SQL query work. We have a location where we have that information. That's the table. We're assuming it's in one table. We have a couple conditions here, right? So we have they have to be a customer. They have to have purchased something from us. That's how we're defining it. It has to be within the year 2024, right? And now we're trying to figure out the top part. That's interesting. So if I were to do a query on all the customers, if I were to ask this question, I'd be like, and I get back a bunch of random numbers with customers
Mhm.
versus their sales in 2024. One might say $5, one might say $5 million. Well, I want to have a way of ordering this now, right?
Mhm.
So that's where it comes in. So that $5 million customer probably spends more than the $5 customer.
Mhm.
But then, oh, geez, this other customer XYZ, they spent $10 million. That actually go above the 5 million. So that's an order by in SQL, right? So now I have
Mhm.
basically a SQL query where it'd be, maybe select customer
So
name, dollar amount, and then you structure it that way. But that's essentially when you're going your SQL queries, that's how you would talk to your data, is thinking about it that way.
I have a question. So like you mentioned about talking to your data, that just means like you just categorize them. So like for example, you mentioned about like the $5 better than like $5 million customer or like a 5 million customer or something. So like basically how you rank your data. And then
Yeah.
so SQL is kind of um like how you, for example, let's say we call like tier one customer, like we just use like the number one as example, and then tier two customer, which is like I don't know, people who there's a lot of customer but don't spend a lot of money, and then the tier three would be like the people who never spend money or whatever. So those are labeled as like numbers, like I don't know, 1 2 3 or something, and then like SQL is like how you kind of like categorize and processing them.
Yeah, you can ask questions with SQL. The cool thing with SQL too is you can actually create these tables that through the custom logic you have would be able to categorize that. So you could have a field like tier, and that would just
Mhm.
be you probably do it through a case statement, like case when revenue is between these
Mhm.
numbers, give the tier of this number, and that's
Mhm.
lower ones get these other numbers. So yeah, so SQL is a way of it's become sort of the standard way of interfacing with most databases, not all, but most. And that means you can ask query type questions where you're just asking it a question, but you can also have it do stuff, right? So this is called DML, domain manipulation language. So that means you're actually
Mhm.
having it. You can create tables, you can insert values into it, you can delete, you can update values within tables. So you can think of SQL as really the way you interface with your databases. Now, you'd mentioned a couple things like data warehouses, data lakes, data lakehouses, databases,
Yeah.
SQL, and so forth, right? And so if you think of
Why
it,
are they related to lake? And I mean, I understand
I
the
don't know where they came
warehouse
up with these
part,
names.
but
Warehouse came about. It's my friend Bill Inman came up with it, and actually, I think he was telling me that the name data warehouse, they came up with it in some random place in Canada one day. I think it was an oil company, and just it's called a data warehouse. And it's like, great idea, let's do it. But the data lake, I'm not quite sure how that came about. And NoSQL actually means not only SQL, so it doesn't
mm,
mean like it doesn't use
mhm,
SQL. Um, so Michael Stonebreaker and Andy Pavlov have a really good paper called "What Goes Around Comes Around"
mhm,
again and again, and that paper goes through how pretty much every database ends up becoming like some manifestation of the relational database and using SQL. But that's a bit of a side note. But yeah, but you can think of like SQL as sort of this universal way or language to query any types of databases or data lakes or lake houses, right? And so when we talk about lakes and lake houses and warehouses, you can sort of see the progression where it started with the warehouse and you had data lakes, and now lake house is sort of the fusion of the two. But at the end of the day, these are abstractions to be able to store and query data mainly for analytical processing, right?
mm,
So not for transactional workloads. But what you're seeing is these especially lake house technology lends itself really well to machine learning. and AI
Mhm.
use cases. And so that's sort of the evolution that you're starting to see these days, is being able to land different types of data in one place. It's well managed, well governed, and then you can query it as well. So hopefully that answers your question, but there's a lot to it. So,
Totally. What is Spark?
okay, Spark is well, it's a lot of things now, but it's a data processing framework
Mhm.
at the end of the day. So yeah,
I want to be mindful of the time, but
yeah,
like,
no worries.
uh, maybe is this okay if we ask one more question and then we
Sure.
just wrap up? Okay. So, I guess like, what is like the most exciting trends that you're seeing in 2025 in the data engineering space? I know it's like a very huge jump from our
AI is
one-on-one
always the
talk.
big one, right? But I want to take kind of the other approach, and I think what I find interesting is you have there's obviously really cool stuff happening on almost an hourly basis in the AI and data technology space. But I think from a practices standpoint, what I find interesting is there's almost a reversion back to really basic, really boring things.
Mhm,
So I'm actually excited about, I think, people leveraging AI more in their day-to-day workloads. But I think also coming back and doing things like data modeling, for example, right, which I think was sort of
mhm,
ignored for a really long time. But you're starting to see the consequences of, I think, ignoring good data practices is coming back. And I think what's really driving this is the adoption of AI, where data was sort of almost taking a back seat in some ways.
mhm,
But now, because data is instrumental to training models and making great models, you're starting to see, I think, a resurgence of coming, I guess, a reversion back to quote boring practices. And so, actually, I'm really excited by boring things, is what I should say. So,
mhm. I feel like everyone who listens to like our podcast are also excited by boring things. But I wonder, okay, so I want to give a plug of your podcast, and then I also
yeah,
want to learn more about your takeaways from hosting your podcast.
yeah, yeah. So
Well,
yeah, my
what's
podcast.
your name?
I have the Joe Reis Show is my podcast, and so
Yeah,
that's
you have a LinkedIn Live thing too.
I do. It's coming back actually. So we had the Monday morning data chat, which was Monday morning at what would be 8 a.m. Pacific
Yeah.
time, but kind of ditched that. But I'm going to be resurrecting a live show pretty soon, probably in the middle of the week. So stay tuned on that. That should be happening pretty soon. Um, but yeah, my podcast, the other one I do was just pre-recorded, and I have all kinds of guests on there. It's a very interesting mix of people, but the whole thing is it's not scripted. We just have very candid chats. So I kind of think of it more as a chance to chat with friends about what they're up to. So the one coming out this week is with my friend um, Evan Wimpy. So he's a comedian, and then we
Mhm,
also have another chat. What was it? Day-to-day Texas. I think that just went live today, actually. So I do several podcasts a week, several episodes. I usually do my unhinged rants on Fridays, where I just talk to the mic and I don't know, talk about whatever's in my mind. But podcasting is one of these things. If you're asking for tips on podcasting, or it's I would say get comfortable with it. I mean, if I counted correctly, I've probably done almost 1,000 episodes between
yeah.
myself and other
Oh, wow.
people.
Mhm,
So it's one of those things where I think you just do it and you get really comfortable being on the mic, like
mhm,
almost to a bad degree in a
mhm,
way, because you're
mhm.
almost overly comfortable.
I
But
feel you. I have like maybe 500 or something. So I did like maybe like over 300 last year,
wow,
but I like but it's like a bit not 300 like well 249
still a
on the
lot.
official thing, but like I also recorded like I batch like a bunch of stuff like that haven't aired yet. But I'm like a very slow error, so I can only do stream. Yeah. But
Yeah.
I wonder, like, is there any resources that you recommend? Obviously, I would name one, which is like DeepLearning.AI that, or Coursera, but like, is there something that you recommend for the normies to take? Just because I feel like even for DeepLearning.AI or like some other stuff, like, I feel like although it sounds like it doesn't require any background, but like, I feel like whenever I go and learn, it's like kind of like not translate into like how like, I guess consumer people think though.
Yeah, I would say the course I did for deep learning AI, that was a data engineering course, 16
Mhm,
weeks, but it's an intermediate level course, right? Like I think you could jump in, but you still need to know some basic coding and,
mhm,
but I'm pretty gentle in that course. So, if you don't,
mhm,
I think we made it so, if you're coming from nothing, you'll feel supported and whatnot. YouTube's great. There's a lot of great resources out there. Ben Rogojan, Seattle Data Guy, has a lot of great stuff.
Mhm.
Zach Wilson has his just a tremendous amount of great stuff available. If there's boot camp or through YouTube. So it's sort of the golden age if you wanted to learn stuff. But the problem is there's almost too much stuff out there, and so you really need to sift through and curate.
Yeah, I think another problem is like I don't think like just like people are lack of motivation to actually build something. Because imagine if you have like an actual job in like I don't know marketing or something, and then your day to day is like not really driven by okay, I built this amazing like app. It's more towards like what can I get from like my financial result or like some sort of like
Yeah.
result to me using a date like AI app that does XYZ. But though like you want to understand like as like a hobby, you want to understand like how did engineering work. But obviously I personally think there's a lot of like fundamental value from like learning about these things. But on the other hand, it's like kind of hard to translate into like a day-to-day function to like motivate yourself to like keep on going though.
Oh, for sure. I mean, you definitely have to start with a why. Like, why are you learning this stuff? Because
Mhm.
learning tech is one of these things where I feel like if you don't have the motivation or a why, um, you'll run yourself into circles, and you'll go through what's called tutorial hell. You'll see a
Mhm.
bunch of tutorials, but you'll forget about it, right? So
Oh,
I think you
yeah,
have
that's
to have
exactly
like,
where I am, like, tutorial
yeah.
hell. Like, I feel like I learned so much like, well, I watch all these, like, because we have, like, the, Alex the Analyst on the show, and then we
Oh,
have,
he's
like,
a good dude. Yeah.
Nick from so, like, Nick Singh. So, like,
Yeah.
on the show,
Great
so, like,
guy.
a lot
Yeah.
of these, like, great data gurus on our show, but the problem is I feel like a lot of it were, like, just myself, like, losing understanding of it because of like I feel like it doesn't really touch up on like my day to day. As sure I use ChatGPT, but like uh like I don't really understand how to apply this into like a daily life though.
Yeah, that's the hard part, right? And it's the crux of anyone who's learning, even people like me. I'm always learning stuff, but it's one of these things where if you're not going to use it, then it's almost like you got a lot of other things to do with your time. So I would say just find things that are applicable. Like there's no shortage of books to read. I mean, I have books everywhere right now, and it's like a lot of them I've read. Which one? Yeah, but it's crazy. I'll pick up a book that I know I've read, and I'll read it. And like I don't remember reading that. That's crazy. So that just goes to show. Or if I even my own book, fundamentals of data engineering,
You
I'll go
don't
back
write
through
your
and
own
read.
book?
I'll read pages of it. It's like I don't remember writing that. That's crazy.
Oh. Okay. So why don't we wrap up with like a quick 1 minute fire run? Okay,
Yeah.
what's your favorite book?
Poor Charlie's Almanac by
Oh,
Peter Kaufman. It's
that's
about Charlie
fantastic.
Munger. Hmm.
Yeah. Oh, I'm surprised it's not like anything about data, but who made the biggest impact in your career?
Uh, Probably Charlie Munger, actually. The one who's
Why?
the book's written about. I just
Why?
think he's an interesting person. He's definitely the smartest person I've read, and I actually met him once. But it's like he's just wise. I mean, I think there's really smart people, then there's him. I think
Um,
even Bill Gates said he's the smartest guy he's ever met. So that should say something.
wow. Um, who will you invite to your dinner party?
Say again?
Who would you invite to your dinner party?
Uh, that's a good question. You would be fun.
Oh, thanks.
There's a lot of
Yeah,
friends I
I
didn't
thought
met.
you were
Yeah,
gonna
I don't want to I
cancel
don't
me
want to name any
after,
names.
but
Yeah, there's
yeah, you're
yeah.
like, oh my god, did this girl just grill me on these like the most basic stuff of all time?
No,
I
it'd
did.
be fun. Yeah. A lot of my friends and probably people I don't even know. That's always fun. I think the ideal
Yeah.
dinner party are people I think that are about as opposite, but about as but they're all friendly. That makes for a good time.
Yeah, I mean,
So
like honestly, I feel like I like to chat with people I don't know because I feel like if it's just like your friends, you already know. I mean, although I love them, but like on the other hand, I feel like it's you're not really like opening to like new perspectives on life.
yeah, exactly. Like invite your friends, but have them invite their weirdest friends too. But as long as
Yeah.
they're like not gonna destroy things or
Oh
do
god.
stupid things. Yeah.
Um, where can we find you outside of work?
Say again.
Where can we find you outside of work?
Like where am I at if I'm not working? Um, that's a good question. Like I'm usually at the climbing gym. I
Oh,
was just
climbing
there.
gym?
Yeah, which is such a cliched tech thing to say, but I've been climbing for like 30 years.
Oh,
So
wow. Well,
yeah.
you look 30, so
Thank you. Yes,
yeah.
I'm a bit older than that, but where else? Usually in the mountains here. I live in Salt Lake City, so I'm usually out trail running or hiking a lot
Yeah.
too.
Wait,
So
what is the tax scene like in Salt Lake City?
there is a tech scene here.
There is a tax scene?
Yeah, they call it Silicon Slopes, but if
Oh,
you
what
go to
does
the
that
Bay Area a
mean?
lot, like I go to the Bay Area, it's like, yeah, it's a scene, but a lot of places have scenes. There's a lot of data talent here though, which I think it's interesting. So
Why? Why
I
do
don't know. I
people
don't know what's in the water here, but there's good
maybe
people.
it's
But
it's a data lake.
hey,
A
like,
data lake?
but yeah, lots of nerds here. But when I'm back home, I actually don't go out that much. I travel a ton, so I might actually um if I'm back home, I actually am kind of a hermit. So I'm usually out in the mountains by myself or climbing outside when I can. So
Yeah,
that's about it.
totally. Okay, so, well, Joe, thank you so much for coming on the show.
Yeah,
Is
thanks.
there yeah, I feel like you're such a vibe because of you're another podcaster, just because whenever I chat with a podcaster, the vibe is different. Like,
It is.
yeah, I feel like normally guests are, like, pretty, like, nervous and stuff. You're like, "Oh my god, I can finally relax after giving these, like, guest lectures on, like,
No,
how."
I get to answer questions. It's different, right? But maybe next time we do a podcast, we can just ask each other questions, and that would be kind of fun too. So I'd love
Oh
to
god, yeah,
understand how
totally.
you do podcasts and what you're seeing out there. So that would be fun. Yeah, but
Yeah.
yeah, having a podcaster on your show is always interesting because it almost feels like it's very meta in that way, where you're kind of doing a podcast
Yeah, I never
about
really
podcasts.
talk about podcasts on my podcast. I mean, I go on other people's podcasts to talk about podcasts, but, like, I don't, like yeah, I feel like I do get these questions a lot, but on the other hand, I feel like, I like to, like, learn about other stuff more than, like, podcasts.
Well, I can have you on my podcast and we can talk about a venture or something like that. That'd be kind of
Okay,
fun.
let's do
So
it.
yeah.
YOLO.
Hello.
Thank you. Wow,
Yeah, of
like
course.
oh, thank you so much. I appreciate you, Joe. Let me
Yeah.
quickly
Thank
end
you.
stream. It's about to end.